Hello students, let us continue with our discussion on hyperbola. In the previous video, I had introduced you to a standard form of the hyperbola. And we know that a hyperbola is said to be in the standard form if its center coincides with the origin and the two foci lie along any of the two coordinate axes, the x-axis or the y-axis, and accordingly we have two standard forms. First, where the foci lie on the x-axis is called as the horizontal hyperbola, whereas the one in which the foci lie on the y-axis is called as the vertical hyperbola. So today we are going to consider the equation of the hyperbola, that is the standard equation of the hyperbola. Now let us take up the horizontal hyperbola. We'll find the equation of this hyperbola, and accordingly we will extend it to that of a vertical hyperbola. So consider a horizontal hyperbola and let P be the point xy lying on the hyperbola. Since it's a horizontal hyperbola, both the vertices as well as the foci, they lie on the x-axis. Now, since P lies on the hyperbola, it will satisfy the condition for it to be on the hyperbola, that is its distance, the difference of its distances from two fixed points, that is the two foci, would be a constant. But in the previous video we had found out the constant is equal to 2a, and so we get pf2, because it's always the bigger distance minus the smaller distance. So pf2 minus pf1 equal to constant, which is equal to 2a. But pf2 is the distance between the 2 points xy and minus c comma 0, and so it will be equal to square root of x plus c whole square plus y minus 0 whole square, whereas pf1 is the distance between the 2 points xy and c comma 0, and so it will be the distance would be square root of x minus c whole square plus y minus 0 whole square. This will be equal to 2a. Now in order to solve it, we have to square it, but for that we will remove one of the square root terms to the other side, and so we get, taking this to the other side, we get square root of x plus c whole square plus y squared is equal to square root of x minus c whole square plus y square plus 2a. Now at this stage we square both sides and solve, cancelling out the common terms on either side of the equal to sign. We ultimately get square root of x minus c whole square plus y square is equal to c by a x minus a. Now since there is another term with square root, which in order to remove it we will have to square both sides once again, and we get this kind of an equation, which on solving gives us x squared a squared minus c squared over a squared plus y squared is equal to a squared minus c squared. But for a hyperbola we know that c squared equal to a squared plus b squared, so a squared minus c squared would be minus b squared. So dividing throughout by minus b squared, first of all we replace a squared minus c squared by minus b squared. Now dividing throughout by minus b squared, we get x squared over a squared minus y squared over b squared equal to 1, which is the required equation of the hyperbola. So we notice here that it's an equation similar to a horizontal ellipse, but with one change, that is instead of a plus sign here we have a minus sign here. Denominator of x squared is a squared, which gives us the transverse axis. Denominator of y squared is b squared, which gives us the conjugate axis, as y is along the conjugate axis and x is along the transverse axis. Now similarly, the equation of the vertical hyperbola is y squared over a squared minus x squared over b squared equal to 1. Similar terms here, the denominator of y squared gives us the transverse axis, whereas denominator of x squared gives us the conjugate axis, as in this case along y-axis we have the transverse axis and along x-axis we have the conjugate axis. Now some important observations which we observe here, which we see here are hyperbola is symmetric about both the axes. Second point, the foci always lie on the transverse axis, and it is the positive term whose denominator gives the transverse axis. This is very important point. Now, unlike an ellipse, irrespective of which term has the bigger denominator, it is the positive term which decides the type of hyperbola. That is, if x square term is positive, it is horizontal hyperbola and its denominator gives us the transverse axis, whereas if y square term is positive, then it is a vertical hyperbola and its denominator gives us the transverse axis. Now let us do some questions from the exercise 11.4 which will make the concept more clear. Okay, so let's take up question number 1, which is x squared over 16 minus y squared over 9 equal to 1. Clearly it's a horizontal hyperbola as the x squared term is positive, and so the denominator of x square will give us a square, that gives us a equal to 4. Denominator of y square gives us b square, that is b is equal to 3. And also for a hyperbola we have c square equal to a square plus b square, and so c square comes out to be 25 and c is 5. Now, to find the coordinates of the foci, we know that in case of a horizontal hyperbola, the foci and the vertices both lie on the x-axis, and so the coordinates of the foci are plus minus c comma 0, which gives us plus minus 5 comma 0. Coordinates of vertices also lie on the x-axis, and so it is plus minus a comma 0, which gives us plus minus 4 comma 0. Now to find the eccentricity, we know that E is C by A, which gives us 5 by 4, which is greater than 1, and so a hyperbola. And now length of transverse axis is 2A, which is 8. Similarly, let's consider the second question. It says that y squared over 9 minus x squared over 27 is 1. Clearly it's a vertical hyperbola as y squared term is bigger. So denominator of y square gives us a square, and that of x square gives us b square. Now here a very important point to be noted is that even though a is less than b, even though the denominator of y is less than that of x, but still because y square term is positive, so it is a vertical hyperbola, and the denominator of y squared only gives us the transverse axis. Now again, for a hyperbola, c squared equal to a squared plus b squared, and so we get the value of c squared as 36 and c as 6. And now we find the coordinates of foci, vertices, both of which lie on the y-axis, and so will be written as 0 comma plus minus c and 0 comma plus minus a. So the coordinates of foci are 0 comma plus minus 6 and 0 comma plus minus 3. Eccentricity E is equal to c by a, which is 6 by 3, which is 2, which is greater than 1, and the length of the transverse axis is 2 times a, which is 2 into 3, which is 6. On the same lines, you can try out the other questions of exercise 11.4 also. Thank you.